All right, how about this first one up here? What are you looking for immediately?
The oxidation number?
No. Go ahead.
You're looking at the prefix, like tri and ri.
You're looking at a formula.
Cation.
No.
No.
Type of bond. What are you doing? Why are you looking for bond type? Yeah. So if I'm looking at a compound and it starts with an H, I need to name it as if it's an acid. If it's got a metal in it or a polyatomic ion in it, I need to name it as if it's an ionic compound. If it doesn't have, if it's just all nonmetals, then I need to name it as nonmetals. Unless it starts with an H, then I need to name it as an acid. So I can't just start throwing stuff down. The first thing I need to do is it ionic, is it covalent, is it an acid? And then I decide how I'm going to name the thing. Okay, so what am I doing with this first name here? How do I name this first one? Say again?
Aluminum.
What bond type is it? What bond type is it? Is this an acid? Is this a covalent bond? It's ionic. How do you know it's ionic? There's a metal there. Okay, so I look at this and I say, hey, there's aluminum there, there's a metal, then I need to name this like an ionic compound. And so the oxidation number for the aluminum, what would that be? Oh, I didn't realize. That's a second question. Yeah, all right, let's just do the oxidation numbers. So the aluminum is a +3. How do we know that? Its position on the periodic table and the fact that it has a fixed oxidation state. And then the nitrogen?
-3.
How do you know that? Because it has to equal 0. That's why. I don't know it because of nitrogen's position on the table. I know it because I know aluminum's charge. And so then the aluminum, or the nitrogen, has to make it 0. All right, how about the potassium? How do you know that? Position on the table, group 1 metal. Okay. And then the oxygen's charge? How do you know that? It's not always that number. There's 2 potassiums. I know the potassium's charge are each +1, so there's only 1 oxygen, so it's got to negate all of that by itself. All right, the sodium?
+1.
Yeah, it's 1 because it's in that first column. The hydrogen?
+1.
How do you know it's a +1 and not a -1? There is a metal there.
Because we worked it back, or I worked it backwards.
Okay. But there's another way we can do this. This is an ionic compound, right? We okay with me saying that? Give me the 2 reasons why this is an ionic compound. There's a metal. There's a polyatomic ion, right? There's hydrogen carbonate. So this thing right here is a thing by itself, right? It is a thing that can be by itself. This is the major buffer of your bloodstream. You've got a ton of hydrogen carbonate or bicarb or whatever it is we want to call it inside of your bloodstream. So really this HCO3 negative is floating around by itself. So what is that hydrogen bonded to?
Carbon.
And
Oxygen.
so those things, what do they have in common? They're both what? They're both nonmetals. And the rule for hydrogen is if hydrogen's with nonmetals, its charge is +1. So it's not with that sodium. That sodium's just stuck to it because it's negatively charged, but the hydrogen is actually chemically bonded to the carbon and the oxygen, which forces its charge to be plus because those 2 things are nonmetals. Okay, can you figure out what the carbons is, or should we do something else first? We should do the oxygens next, because the oxygen is almost always, not always, but almost always -2. And so, since there are 3 of those things, what's my carbon's charge gonna end up being? +4. So I've got -6, right? And then +4, and then +1 and +1. So it all cancels out to 0. All right, next one.
Should you do the parentheses first?
This is asking about atoms' oxidation numbers, so I don't care about the parentheses.
The OH is -1, but there's 2 of them.
I asked you about the atoms, though.
Oh.
Uh-huh.
Well, it's a metal bonded with a non-metal, so
Okay,
it's ionic.
all right.
So,
What's the metal's charge?
+2, yeah.
And you know that because it's in column 2? Okay, so do you know what the hydrogen's charge is?
Well, can figure that out.
Well, okay. I don't need to figure anything out. It's with oxygen, right? It's with that O. That is a hydroxide. That oxygen and hydrogen are bonded to each other. And so same as the last example, right? The hydrogen is connected to a non-metal, so that hydrogen's charge is a +1. So what I have right now is +4 total, right? Is everybody okay with me saying that, since there are 2 hydrogens? Sarah, you all right with that? Okay. You're the only one that didn't nod, so I wasn't sure. So I've got 2 hydrogens, and so then I need to cancel that out with 4 negative charges, but I only have 2 atoms left. They're both oxygens, so I'm just going to go ahead and make both of them -2, and then it all works out. All right. So let's do what we do when we name something. So I look at this, and I see that there's a metal in there, so I say it's ionic, so then I have to name it accordingly. It's okay for me to just say aluminum. So why is aluminum nitride the name for this ionic compound? Why is there no Roman numeral there? Aluminum has a fixed oxidation state. I don't need to tell you what it is because it's always +3. And the anion I hacked the end of it off to "ide." Does anybody know what the other pronunciation for this is?
For what? The
Aluminium. No? Yes? Nobody's heard that before?
I've heard it.
Aluminium is where most of Europe says it. And definitely British. Absolutely. If you've read anything British or a television show, like you watch the Sherlock show that's on PBS, whatever, they'll say aluminium and you're just like, what is that, like a made-up element they have for the X-Men? Like enantium? No, it's actually them pronouncing aluminum the way they think it's supposed to be pronounced.
Do they say like aluminium foil?
Yes, they do. Wherever we say aluminum, they say aluminium, and they call us idiots. And since they speak better than us, maybe we are.
They kind of started English, so.
Yeah. Well, I don't know about that, but
Well,
that would be a very long discussion. Okay, next
It
one.
originated in America.
It definitely did not originate in the United States or the North American continent. Yeah. Okay, so what do we want to do next? I look at this thing and I see what? I see potassium, it's a metal, I name it as an ionic compound, great. So, why no Roman numerals? Fixed oxidation state. Okay. So the implication of that is or going backwards, when I'm giving you the name and you have to come up with the formula, you're supposed to know that the potassium's charge is +1. And you're supposed to know that the oxidation state of the oxygen is going to be -2. That way you don't write down KO, you write down K2O. Next one. ionic compound, right? Metal and a polyatomic ion. So what do we got here? Sodium.
Hydrogen carbonate.
The other name for this, just in case you come across it, sodium bicarbonate. The old nomenclature for hydrogen attached to a polyatomic ion was the prefix bi. And then the super common name for this? Goes in bread. Baking soda. Okay, and then the last one? Metal there, polyatomic ion there, ionic compound. So how do I name it?
Magnesium hydroxide.
Alright. Do I need to deal with the fact that there are two hydroxides there? Do I need to indicate that? I don't. You're supposed to know that the magnesium is a +2 and the hydroxide is a -1, and then when you build the molecule, put it together correctly. Alright, so tin 2 chloride, what's that formula going to be? When I look at this, I'm like SN with a +2 charge, and chloride usually has a -1 charge, so SnCl2. That's how I would approach those. The sodium phosphate, what's that one look like?
You skipped the first one.
Oh, sorry about that. Yeah, I did. So that's a Zn with a +2 charge. What was special about the zinc? The zinc, cadmium, and silver. Yeah, even though it's in that area where it usually has a variable oxidation state, it doesn't. So you don't need to say zinc 2. So then it's just going to be ZnSO4 because the sulfate's charge is going to be a -2. All right, how about the sodium phosphate? So I've got a sodium, right? It's got a plus charge. What about the phosphate? What's its charge? Did you say a lot? It's -3. Okay, so how do I put those things together?
There's gotta be
Three
three sodiums, yeah.
sodiums. So the actual chemical name for this is sodium phosphate, but you can purchase this in the hardware store. I don't think I've actually ever seen it sold in a grocery store before, but it's definitely sold at hardware stores as this. I don't know if you've seen a box with that name on it, but TSP stands for trisodium phosphate. Does that name make sense? Yeah, it totally makes sense. And if I was doing the nomenclature for stuff, that would be the name of this. That way we're absolutely, totally, 100% clear. This thing has 3 sodiums on it. But instead, you just have to remember that sodium's a +1 and phosphates is a -3, so then you need 3 of them. So the common name for it is trisodium phosphate, TSP. That'd be a wrong answer for a test, but does anybody know what this is for?
I use it to clean walls, before I paint, sometimes before I do.
Oh yeah, absolutely. So this is a salt that is also a really strong base. And bases are really good at getting oils and any lipids. It actually chemically turns those things into soap. So if you've got like a wallpaper up, or there's been especially good for a kitchen. Let's say a kitchen was painted and you want to repaint it. You need to get that. You can't just paint over the top of a kitchen wall because there's going to be grease and oil and whatnot just because it vaporizes, so it won't stick well. So you have to clean that wall off, and if you use a solution of trisodium phosphate, it literally turns that grease that's on the wall into soap, and then you just wash it off. I have used the hell out of this the first year or so that I was in the Navy, because when you're not doing anything, they just make you clean stuff. I mean, it's already clean because there's so many people not doing anything. So like this floor, how do you clean this floor? Do you know what's on top of this tile? Wax. So it's just wax. It's just like chapstick, just thicker. So the chain of carbon is longer, and so it's a little bit more solid. but when we're walking in and out, we're bringing in like tiny rocks and little bits of dirt, and when we stand on it, it gets ground into it, so eventually the shine disappears, right? So I gotta clean the wax off and take all that dirt and rock and whatnot with it. How do I get the wax up? Trisodium phosphate. I just throw it around on top of it, and what happens to the wax? Turns into soap, and I clean the floor. It's not fun, and you don't want it on your hands. It's as bad as concentrated bleach water, which would also work to clean these floors off and clean your kitchen walls off. But why don't you want to use that?
Does it take everything off?
Not necessarily take everything off, but it's very volatile. Turns into a chemical. Well, so is that. It's that its toxicity can be turned into a gas, and then you're breathing it. Where this one doesn't turn into a gas. All right, so charge on the silver. +1, and the sulfide. Where is it on the table? -2. How do you know it's -2 based off of its position on the table? It's right below oxygen. Yep. So then what's my formula going to be? Ag2S. All right. And then the last one. I should have changed that one. There we go. All right.